Also use the law of sines to find angles, and we do that in the case where there's a side, and another angle. So if you remember back to those similar triangles and congruent triangles, this was the case that could not prove that triangles were congruent, but we can still use the law of sines in this case. So look at the little notes that we've got there. When finding angles, it is possible to have one solution, two solutions, or no solutions. And that is called the ambiguous case because it could be any of those three. So you got to make sure that it is possible for the situation to exist. So let's remind ourselves, first of all, that the sine function always has a range between -1 and +1. That is important because when we are solving these, if we ever get the sine of an angle by itself and it's equal to something that's greater than 1, that's the case where we have no solution. Okay? If the sine function is positive, then the angle can lie in quadrant 1 or 2. So that's where we have more than one possibility sometimes. Because we can have, let's just use an angle off the unit circle. A sine of an angle equaling 1/2, well, that could happen at 30 degrees, or that could happen at 150 degrees. 30 degrees and 150 both could be angles in a triangle because they're both less than 180. So that's where we have two possible options. So to find the other possible angle, then we will subtract from 180 degrees. Now we know this one, but let's write it down just to be on the safe side. The sum of the angle measures in a triangle is always 180 degrees. And no triangle can have two obtuse angles. What's an obtuse angle? Larger than 90. Okay, bigger than 90 degrees. So if you're solving this and you end up with two that are bigger than 90, that's not going to work. Okay, because if you have two that are equal to 90, you're still not going to have a triangle, right? Because 90 and 90 is 180. You don't have anything left for the third angle. So if they're bigger than 90, that's certainly not going to work. Okay, so let's look at question number 7. The measure of angle A is 50 degrees. Side AB is 4. Side BC is 9. Find the measure of angle C. Now, because of the way that this is set up, I would most definitely draw myself a picture. So angle A is 50. And then we're just going to go... It really doesn't matter which one is which, but this is how I'm going to label it. So side AB is 4, side BC is 9. Find the measure of angle C. I don't have room to put an X right there, so I'm just going to mark it with a little curve there. So this is set up perfectly for the law of sines. Sine of 50 degrees, side A is across from that, is equal to the sine of, this time we don't know the angle. That's where our variable is going to go over the side that is opposite of that angle, that is 4. So we still cross multiply. 4 sine 50 is equal to 9 sine of x. This time we divide by the 9 though. So we can work this out, but we're going to want to store it as x because we don't want to lose our accuracy. Okay, so 4 sine 50 divided by 9, go ahead and store that as x because we're going to need it stored as x later on. Anyways, so we get 0.3405 is approximately equal to the sine of x. Now, don't get confused. We've stored this as x, but that is not the x in our equation, okay? Not the same thing, we just stored it in the calculator, okay? Now, think back to math 2, math 3, whatever, how do you find the angle? What do you use to find the angle here? The inverse sign. Okay, we use the inverse sign of the number that's on the opposite side of the equation, because that number is not from our unit circle. If it were from our unit circle, then we could just use one of our angles, but it's not. So inverse sign of, we stored that, so put x right there, is 19.9, and that's an angle, so it's degrees. We're going to keep rounding to the nearest 10. Okay. So that is one solution, is that angle is 19.9 degrees. Now we've got to check and see if another solution is possible. So once we find that one, we subtract that from 180. 180 minus 19.9 is 160.1 degrees. Is that going to work in this triangle? No, it's not going to work, because our other angle that we know of right now is 50. So if we add those two angles together, we're way above 180, and we haven't even talked about the third angle of a triangle. So this triangle only has one possibility. And it also really wouldn't make sense for that to be 160 degrees, because we already know that that's smaller. That side is smaller than 9, so our angle has to be smaller than 50. So just keep that in mind there. Okay, let's look at number 8. Measure of angle B is 37 degrees. I'm just going to label my triangle the same way I did just a second ago. So B is 37 degrees, AB is 47, AC is 29. Find the measure of angle C. Okay. We don't have to do any extra work here. We have the sides and angles that are opposite of one another. So sine of 37 over 29 is equal to the sine of, technically I can put a C right here instead of an X, so we don't get mixed up when we store that value. And then that way I know that I'm talking about angle C. Okay, so cross multiply 47 sine of 37 degrees is equal to 29 sine of C. Divide by the 29. Go ahead and crunch those numbers and store it as X. 47 sine 37 divided by 29, stored as X. 0.975, that's less than 1, so we are good. That's equal to the sine of C, so we do the inverse sine of that number. So we get that C is approximately 77.3 degrees. Okay, so if we subtract that from 180, we get 102.7. Let's see if if both of those are going to work in our triangle here. We've got 37 plus 77.3. Obviously, that one's going to be okay. That leaves us enough for a third angle. And then 37 plus 102.7. We still have enough for a third angle in our triangle. So we have two possibilities for that angle C there, 77.3 and 102.7. Let's check and make sure that it works with the information that we're given. Both of these angles are bigger than 37 degrees. And the side across from that angle is bigger than 29. So the question is it the biggest side in the triangle, or is it the middle side? We don't know with the information that we're given, but both of those fit within that case.